Hi everyone, welcome to my presentation, and I will be presenting 3 of my textile samples, the Modina collection. The Modina series is an innovative project that embodied a harmonious alliance between the humans and non-humans, particularly the slime molds and spirulina. The core objective is to reveal a symbiotic relationship between the humans and non-humans by integrating the slime molds and spirulina as the active collaborator in the creation of the wearable designs. The project's Modina responds to the pressing concern of the negative environmental impact caused by the human-centered design, while promoting a vision of the more than human-centered design that embraces the mutual reliance on the renewable resources. In the process of working with slime molds and spirulina, the slime molds act as a visual director for both 3D and 2D by programming a slime molds plugin in the parametric designs to effectively generate the paths in converting them into the pattern and models. And spirulina, as a highly nutritional microalgae material, contributes to the environment and human health with its biodegradable and effective CO2 absorption properties. Incorporating these two organisms into the design process has the potential to develop biofabrication lines and the wearable cultivation device for the superfood. In addition to the autonomous growth process of the spirulinas and slime molds, and I also propose a combine to the production of the sample with handicraft skills, as the human are still considered and need to be involved in the design process in a way that cannot be replaced. For my sample number 1, the 2 main techniques used were embroideries and the spirulina biomaterials. I generated the patterns by using the slime mold simulators and then used the hand-freed embroidery to reproduce the designs. It is important to note that the threads used for the embroidery is the alginate fiber, which is 100% biodegradable threads made from the algae and cellulose. The texture of the embroidery retains traces of the handwork, and unlike the purely mechanical embroidery, I wanted to emphasize that the human beings as one of the participants in the project is not totally dependent on the organisms, but rather interdependent with them to complete the design. Once the embroidery is complete, the sample is dipped into the mixture of the spirulina biomaterials and left to dry. After the biomaterial is covered with the embroidery, the overall hardness will be higher. It has the potential to be used as a skeleton material to create a 3D shape wearable designs. In the sample number 2, the pattern is also generated by slime molds, and algae PLA was used as the material to support the shape of the sample. By using a 3D printing pen to fill the hollows of the embroidery with a sandwich structure, the filaments need to be filled twice from the front and the back sides respectively to prevent the PLA from peeling off on the embroidery. By fixing the shape of the textile through the 3D printing, it will better fit on the user's body and provide a distinctive textural experience. The combination of the algae PLA and alginate fiber embroidery enhanced both visual and tactile elements of the design. In my third sample, the 3D printing and the macrame tube are the main techniques applied. As shown in the picture, the longest tube is the water intake, and the 3D printed part at the bottom is the model generated by slime mold. To improve the flow of the liquid in the tube, I made a sample by using the 2 tubes as one stream of the line, which can better ensure that the curve of the tube bending will not be deformed. The 3D printing and macrame-based structure has the potential to be developed into a wearable spirulina cultivation device. The frequency of the spirulina capture is usually between 1 and 3 weeks, and the user could wait for the spirulina to multiply enough and then harvest it for food and so on. These 3 samples demonstrate working with slide molds and spirulina and combining the different handicraft techniques. Importantly, as the slide mold simulator can generate 3D models, these 3 flat samples have the potential to be developed into the 3D shapes applied to the wearable design. The image shows the 3 different design sketches based on the structure of the 3 samples. Exploring this further, I continue to use the parametric design to generate the 3D models grow on the human body and 3D print them in the real size. In the same steps as before, the embroidery dipped into the biomaterial is wrapped around the 3D printed model as a support for the shape. The skeletal effect resembled a hard net wrapped around the human body. Unfortunately, due to a large experimental size of this prototype, the biomaterial took a long time to dry, so I was not able to demold the prototype to show the result. Furthermore, I tried the sample number 3 further. Based on the design I sketched, the 3D printed model would be drilled and threaded with the macrame tubing. The spirulina will flow through the macrame tubing, driven by an electric water pump, and the chest hollow-out part will be placed in the container to view the water level. Due to the time limitations, I made a prototype of the 3D printed part, and macrame tube is not finished yet. However, based on my earlier experiment using an electric water pump to test the sample flow, it is possible to justify the future application of the sample number 3. Thank you for watching my presentation and hope you enjoyed the video.